Chi-square is a non-parametric test. There is two types of test, parametric and non-parametric. So chi-square is a non-parametric test of statistical significance and is also known as a cross breaks. An appropriately performed test of statistical significance lets you know the degree of confidence you can have in accepting or rejecting an hypothesis. Chi-square is used most frequently to test the statistical significance of a result. Reported in vibrant table, and the interrupting the vibrant table is interpreting the result of chi-square test. So chi-square test is developed by Carl Pearson, and when the data is measured, chi-square test is a non-parametric test. It is developed by the Carl Pearson, and when the data is measured in terms of attribute or quality, it is intended to test whether the difference in the distribution of attributes in a different group is due to the sampling variation or not. And the chi-square test is applied. It is used to test the significance of difference between two proportions and can be used when there are no more than two groups is to be compared. So the chi-square test is used when there are more than two groups to be compared. For example, if there are two groups, one of which has received the oral hygiene instruction and the other has not received any instruction, and if it is desired to test the occurrence of new cavities associated with the instruction, so we have to use the chi-square test in such situation. So as mentioned before, chi-square is a non-parametric test. It does not require the sample data to be more or less normally distributed. What is the requirement of chi-square test? The sample must be randomly drawn from the population. Data must be reported in the raw frequency, not in percentage. Measured variable must be independent. Value categories on independent or dependent variable must be mutually exclusively or exhaustive. Observed frequency cannot be too small. As with any test of statistical significance, your data must be from the random sample of the population to which you wish to generalize your claim. You should only use chi-square when your data are in the form of raw frequency count of things in two or more mutually exclusive or exhaustive categories. Any observation must fall into only one category of value of each variable. For example, male versus female undergraduate expressing a preference of 5 different categories of footwear. Each observation or subject is counted only once as either male or female and is preferring sandal, sneaker, leather shoes, etc. and other kinds of footwear. Furthermore, use chi-square only when observations are independent. That is, no category or response is dependent upon or influenced by another. Chi-square is approximate test of probability of getting the frequency you have actually observed if the null hypothesis were true. So it is based on the expectation that within any category, simple frequencies are normally distributed about the expected population value. So this is how we have to calculate it. This is the example. I already given you the example. Now comes a student t-test. Its name is given by Gosset in 1876 to 1973. They developed a statistical method to solve the problem stemming from the unemployment in bravery. The student t-test deals with the problem associated with the inference based on a small sample and the calculated mean, and the standard deviation may be chance deviated from the real mean and the standard deviation. That is what you are measure if you had many more data item and a large sample. This test is used when we would like to compare the mean of particular population to a hypothesis value, and when the sample size is small. T-test is used to test the hypothesis. This test was designed by W.S. Gossett at Atoll, whose pen name was Student. And hence, this test is also called as student t-test. This test is applied to unpaired data of independent observation made on the individual of two different or separate groups, or a sample drawn from two populations, to test if the difference between the mean is real or it can be attributed to sampling variability. It is applied to find the significance of a difference between two proportions. So you may be wondering why the name, I already told why the name student is given. There are some criteria to apply the t-test. The sample must be randomly selected. The data must be quantitative. The variable is assumed to follow our normal distribution in the population, and the sample should be less than 30. Then there are paired sample t-test, independent sample t-test, and analysis of variance, that is Anova. So what is paired t-test? Very often the two samples to be compared are not randomly selected. The second sample is the same as the first after some treatment has been applied. It is applied to pair the data of an independent observation from one sample only, each individual given a pair of observation. Example, to compare the pulse rate of an individual when given two different type of drug like adrenaline and non-adrenaline. Two effects of two different hypnotics. So the number of point in each data set must be the same, and they must be organized in the pair in which there is a definite relationship between each pair of data point. If the data were taken as random sample, you must use the independent test even if the number of data points in each set is the same. If the data is related in the pair, sometimes the paired t-test is inappropriate. Hence, a simple rule to determine the paired t-test must not be used. If a given data point in a group 1 could be paired with any data point in a group 2, you cannot use the paired t-test. Then what is unpaired t-test? This test is to compare two small set of quantitative data when samples are collected independently of one another. When one randomly takes replicate measurement from the population, he or she is collecting an independent sample. Only there is a direct relationship between each specific data point in a first set or one only specific data point in a second set, such as measurement on the same subject before and after, then paired t-test may be appropriate. If samples are collected from two different populations or from randomly selected individuals from the same population at different time, use the t-test for the independent sample, that is unpaired t-test. Here a sample check to determine if a paired t-test can apply. If one sample can have a different number of data points from the other, then the paired t-test cannot be applied. Now comes the Anova. Anova is analysis of variance. Sometimes it is also called as F-test, and it is closely related to the t-test. The major difference is that where the t-test measures the difference between the mean of two groups, and Anova tests the difference between the mean of two or more groups. So there is difference between the t-test and Anova, that where the t-test measures the difference between the mean of two groups, And Anova test difference between the mean of two or more groups. So when you have to compare the two or more group, you have to use the Anova. The one-way Anova or a single factor Anova test difference between the group that are only classified on one independent variable. You can also use multiple independent variable and test for interaction using Anova. The advantage of using Anova rather than multiple t-tests is that it reduces the probability of occurring type 1 error. You can also use the multiple independent variables and test the interaction using the Anova. The advantage of using Anova rather than the multiple t-state is that it reduces the probability of type 1 error. So in short, when the comparison of more than two independent group or continuous outcome is required, we make the use of Anova. This is to test whether the mean of outcome variable is different group are the same. One potential drawback to an Anova is that you lose specificity. To test for this, you use the post hoc comparison to find out where the difference are, which group are significantly different from each other and which are not. Some commonly used for post hoc comparison are these two, Safi and Tafi. Just remember the name. This is how we calculate. We have to compute the total sum of the square, then compute the between the group sum of a square, then compute within the group sum of a square, within a group first, between the group, then within the group, then calculate the degree of freedom for between the group. Degree of freedom is noted by df, then calculate the degree of freedom for the total, then calculate the degree of freedom for within the group, then compute the mean square for each, then compute the value of f by dividing the number of square for difference for between groups and by the mean square within a group, and then finally determine the whether f is significant. This is how we have to calculate. And then comes the computation. Excel, we have to enter the data into the data table and so on. Then these are the non-parametric tests. It is chi-square test, figure-exact test, binomial test, man-Whitty test. Just remember the name, like Wilcoxon test. This is non-parametric. Binomial test. In statistics, the binomial test is an exact test of statistical significance of deviation from the theoretically accepted distribution of observation into the two categories. Figure-exact test. Figure-exact test is a statistical significant test used in the analysis of categorical data, where the sample sizes are small. In this test, it is used to examine the significance of the association between two variables with the large sample. And chi-square test will also be used in such situation. The need for the figure test arises when we have data divided into two categories in a two separate way. Example, a sample of a teenager might be divided into a male and a female on the one hand, and those that are not currently dating on the other. So we hypothesis perhaps that the proportion of a dating individual is higher among the women than among the men. And we want to test whether any difference of proportion that we observe is significant or not. So this slide is showing the parametric test. So T test, Z test, Anova, correlation, regression, and time series analysis. These all are the example of parametric test. These are non-parametric chi-square, phasor exact test, Wilcoxon test, and this is parametric. T test, Z test, Anova, correlation, regression, time series analysis. These are all parametric tests. Now comes measure of association. Measure of association describes the strength of relationship between an exposure and an outcome. So measure of association is the strength of relationship between an exposure and an outcome. Under ideal condition, it would be possible to accurately measure the effect of an exposure by comparing the number of outcome in a group or exposed subject with the actual number of outcome had they had been exposed. And it is not possible to recreate the hypothetical state. The measure of association that can be calculated from the epidemiological studies depend upon the particular study design. In both cohort study and randomized control trial, that is RCT, which are a subtype of cohort study, the study group are determined by whether or not the subject are exposed to a putative cause. So the outcome of interest can be categorized as either present or absent. Subjects who are at risk of developing the outcome are followed over a period of time to see whether or not they developed it or not. In a case control study, however, the group are determined by whether or not the subject having particular outcome of interest, such as a disease with a prior exposure of being assessed retrospectively. Now, what is correlation and regression? The word correlation is used in everyday life to denote some form of association. We might say that we have noticed a correlation between the foggy day and attack of dizziness. However, in statistical terms, we use the correlation to denote the association between the two quantitative variables. Sometimes two continuous characteristics are measured in the same person, such as weight and cholesterol and weight and height. This is just an example. At other time, the same characteristic is measured in two related groups, such as tallness in a parent and tallness in children, study of intelligent quotient in brother and corresponding system. So the relationship or association between the quantitatively measured or continuous variable is called as correlation. When two variable characteristics in the same series or individual are measured in quantitative units such as height and weight, temperature and pulse rate, age and vital capacity of a lung, it is necessary not only to whether it is association between the two, or we should also know the extent or strength of the relationship. This slide is showing the example, showing the temperature and the pulse rate. So there are different types of correlation. There are 5 types of correlation. First one is perfect positive correlation, perfect negative correlation, then the moderately positive correlation, moderately negative correlation, and absolutely no correlation. So perfect positive correlation, perfect negative correlation, moderate